Microgrid Controller Design, Implementation, and Deployment by Team 11, Scott Wilson, Phuoc Vu.
Introduction. What is a microgrid and what does a microgrid do? Motivation. We will explain why a microgrid is such a promising energy distribution system that is cost-effective, sustainable, energy efficient, and stable. Approach. The Philadelphia Navy Yard is a great success story of microgrid implementation. Its design and approach to implementing a microgrid could be studied. And the result is amazingly good. Within 10 years, the Navy Yard project added approximately 10 megawatts of major on-site generation and storage capacity of 260 megawatts, which exceeds its average demand by 100 megawatts. There are currently over 7 billion people living on Earth, and according to the UN, the population will reach over 11 billion by the end of this century. With this near doubling of population, the demand of energy increases dramatically as well. However, most of the energy produced today comes from fossil fuels, and that limited resource is being depleted day by day. What will the future look like if all of a sudden that source of energy is gone? Not a good picture to imagine. A better and more sustainable solution for our future generations is to seek other, more sustainable sources of energy such as wind and solar. Sadly, these resources are currently not being fully utilized. That clean and abundant energy can be stored and distributed into the electrical grid system through something called a microgrid. We believe a microgrid is a smart, environment-friendly, and sustainable approach to our hungry demand of energy.
In southern Philadelphia, just past the sports stadiums, there is a region known as the Naval Yard. This area was a functional U.S. Navy shipyard until the 1990s, when it was decommissioned and converted to a business campus, which it remains today. As an investment opportunity, a green energy initiative, and a demonstration of sustainability, the Philadelphia Industrial Development Corporation worked with the Department of Energy and the Philadelphia Electric Company to implement a microgrid on the Naval Yard. A microgrid is a group of electrical sources and loads that is capable of disconnecting and operating independently from the utility supplier, i.e. PECO, PSE&G, etc. Microgrids can be as small as a single home or large-scale commercial and industrial grids supporting multiple facilities. A microgrid has three major components: local supply, local consumption, and connection to the rest of the grid supported by the utility supplier, or macrogrid. Most microgrids should also include some form of energy storage and a system for safely and properly disconnecting from and reconnecting to the macrogrid. Philadelphia had several good reasons to pursue the installation of a microgrid. With the recent trend of extreme weather events, grid stability is becoming an ever-increasingly important issue. In the aftermath of Hurricane Sandy, many lost power for an extended period of time. Microgrids can help with this by allowing areas suffering less damage to disconnect from the main grid and operate independently. With the rise of popularity of privately owned energy generation sources, such as home solar panels, these distributed energy resources can be easily integrated into a microgrid. Local generation for local consumption can also help reduce energy losses associated with transmitting power over long distances. With the creation of the microgrid at the Naval Yard, Philadelphia strives to continue to be a leader in energy technology, attracting companies, investors, and minds. The Naval Yard's microgrid supply is composed of several sets of solar panels for generation, whose combined output is about 10 kilowatts, and an energy storage unit capable of outputting 250 kilowatts. The loads supported by the microgrid include 2 office buildings, a residential home, and a historical church. Each building has some of its load, primarily HVAC systems, earmarked as controllable to allow for partial load shedding when necessary. A controller unit monitors the health of the system. It decides when to switch to islanded mode and when to reconnect to the macrogrid. It can also shed loads to maintain stability in situations where resources are limited when in islanded mode. The Philadelphia Industrial Development Corporation did extensive testing to ensure that the microgrid system is able to support its loads while in islanded mode. To be successful, the system needs to be able to switch to islanded mode within 0.16 seconds, 10 power cycles of 60 Hz, and remain stable for a minimum of 30 minutes. The system's sources and loads were modeled in a software simulation to determine what system configurations are required for what conditions. The microgrid's controller was connected to simulated components and tested to verify the performance of the control unit. The components were assembled together and given test messages to verify that they are able to properly communicate under stressful conditions. And a live test of the equipment will be performed in which actual control messages will be used and executed by the system. A successful demonstration of the microgrid at the Naval Yard could help popularize the idea of constructing microgrids elsewhere. Ideally, this arrangement could be extended to cover all sorts of residential, commercial, and industrial areas. The reduction in wasted energy from long-distance transportation, coupled with the increased stability of microgrids, make them an attractive option for suppliers and customers alike. Microgrids could also help diversify our energy sources and reduce dependence on fossil fuels, as more and more environmentally friendly distributed energy resources, such as solar, wind, and other green energy sources, are incorporated into the grids.
The Navy Yard microgrid system provides a forward-thinking solution to the high energy demands of future development, and we believe the popularity of the microgrid will continue to grow. Together with the main grid energy system, it will provide a more environmentally friendly energy to customers, from individual to industrial, and everything in between. Many new and innovative products are coming out to support this belief. For example, new solar tiles from Tesla are a great way to generate energy, not only for the user's own needs, but also to put energy back into the system for other high-demand facilities. Microgrids like the one at the Navy Yard are modular, green, safe, and energy efficient. It is green because it uses natural sources of energy like wind and solar. Microgrids are safe because they are monitored and controlled by advanced software in which faults can be easily isolated and service disruption can be minimized. Lastly, microgrids are energy efficient because they reduce energy losses associated with long-distance power transmission. Local generation for local consumption reduces wasted power. The microgrid at the Naval Yard highlights the promising potential for a future in which every home can be turned into a microgrid of its own, able to provide energy for its own daily use as well as contributing any surplus back to the macrogrid.